Hello everyone, this is Dr. Sprons, and today we're going to be working on how to use compound or connectives in creating compound statements. Now in set logic, you need to understand the differences of the statements that we're using, and for today we're going to be using the simple and compound statements. Now simple statements, these are statements that convey a single idea with no connecting words. Example of simple or basic statements in set logic would be today is Monday, Jane is eating a pie, and Bob tries dancing today. So these are some of the basic statements or simple statements that we could use in set logic. Now, what are compound statements? Compound statements are statements which combines two or more simple statements using connectives. And the connectives that we're going to be using in this lesson would be connectives such as and, or, if then, and if and only if. So these are some of the connectives that we're going to be using in symbolic logic. Now let's start our operation for the AND statements, which is defined by if statement P and statement Q are two simple statements, then the compound statement P and Q is symbolized using this symbol. So what you're seeing right now is the symbol that we use for two statements using the AND connective, which is P and Q. Now, how do we use this particular connectives and operation in symbolic logic? So let's say we have two statements. The first statement, which is P, is it is after 5 p.m. and statement Q is they are working. So we have two statements, and we're going to connect this and make it a compound statement, such as the two statements that you're seeing right now. So let's say we're going to transform the sentences or compound statements into a symbolic form. For the first one, we have it is after 5 p.m. and they are working, and since and is a connective in symbolic logic represented by this symbol, we can rewrite this sentence or statements into P and Q using symbolic logic. So this is how we use these symbols and connectives to create a compound statement. And for the second statement, we have it is after 5 p.m. and they are not working. And you will notice that we have negated our second statement, which is they are working. So when we change this into symbolic form, our symbolic form will be P and not Q. So this is how we use symbolic logic so that we can use those symbols in creating compound statements such as what we have in the first example. Now, some of the sentences which uses the AND operation in symbolic logic could be and, but, yet, and nevertheless. So these are some of the connectives that we use, and it will still be the same meaning as the AND operation. So these are some of the examples wherein we are still using P and Q, and the connectives that we're using are different, but the symbols and meaning are still going to be the same. So this is the first set of our connectives, and then the next connective that we're going to be working on would be the OR statement. And the OR statement, just like symbolic logic, if this is the AND statement, the OR statement would be the opposite of your symbol, which is given by this little V symbol right here. So disjunction is another term for the OR statement, which means it is a compound statement formed using inclusive or represented by the symbol that you are seeing right now on the screen. So we can represent two statements as P or Q using this symbol. Now, how are we going to use the connectives to create a compound statement? So now we have two new statements. The first statement, which is P, is going to be the bill receives majority approval, and statement Q is the bill becomes a law. If we're going to change the two statements that we have here in our example into a symbolic form, for the first one we have the bill receives majority approval or the bill becomes a law. So in this statement, we can change this and transform this into P or Q using the symbol for the OR operation. And for the second statement, we have the bill receives majority approval or the bill does not becomes a law. So notice that we negate the second statement again. So when we change or transform this in symbolic form, we can write it as P or not Q. So this is how we use this particular statement or connectives in creating a compound statement such as this. Now let's move on to the third connective that we're going to be using, which is if-then statements. So the compound statement if P then Q is symbolized by P then Q, which you are seeing right now as an arrow going towards the second statement. So in this particular statement, which is also known as a conditional statement, we have two different statements. One is the antecedent and the other one is the consequent. Now, for the first statement, the antecedent would be the statement before the arrow, and the consequent would be the statement after the arrow. So you have a condition or a conditional statement right here, which is the first sentence going towards the second sentence. So how do we use the if-then statements as a compound statements? So let's say we have two statements, P, a person is a father, Q, a person is a male. So if we're going to represent the if-then symbol in this particular compound statement, starting with the first one, if a person is a father, then that person is a male. So since the first statement is P, then the second statement, which is Q, can be represented by this symbol. So P, then Q, can be formed in this particular symbol. And if for letter B, we have if a person is not a male, then the person is not a father. Notice that now we interchange P and Q, and after interchanging it, we also use the negated version of statement P and statement Q. So if we're going to transform letter B into a symbolic form, if a person is not male, it will be not Q, then the person is not a father, which is not P. So we have not Q, then not P in our statement for using the if-then statement. So this is how we use this form of connective in this compound statement. Now there are some cases on how we use this particular operation for P then Q. So for words like then, if is sufficient for, is necessary for, only if, and only if Q and P, then you will be using this particular symbol for this compound statement. And the next operation that we're going to be using would be the if and only if statements. So this if and only if statement is an example of a biconditional statement, wherein biconditional statements are conditional statements that are true if the statement is still true when the antecedent and the consequent are reversed. So let's say we have a compound statement wherein the first statement is if a person is a father, then the person is a male is our antecedent. So notice that the antecedent is if a person is a father, and the consequent is that a person is a male. So we know that this one is a true statement, and let's say we interchange P and Q, and let's see if this conditional statement will still hold true. So when we reverse the statement, if a person is a male, then that person is a father, will not always be true, but not necessarily true. So with this particular statement, we know that we can somehow interchange P and Q. Therefore, this is an example of a biconditional statement given by P if and only if Q. So this one is an example of an if and only statements in this compound statement. Now let's have another one. If a person is unmarried male, then that person is a bachelor. And we're going to say that this is a true statement because we're just defining or giving P or statement P and statement Q using the conditional statement. And if we interchange the two statements wherein the antecedent becomes the consequent and the consequent becomes the antecedent, the statement would become if a person is a bachelor male, then that person is unmarried. So in this case, even though we interchange P and Q, it still holds true. Therefore, we can say that P, if and only if Q, can be used as a compound statement for this biconditional statement. So this is how we use the if and only if statement in our compound statement. If you can reverse your antecedent and your consequent, and the statement still holds true, or somehow still holds true, then this is going to be a biconditional statement. So here are some of the connectives that we use for this particular lesson. We had conjunction, disjunction, conditional, and biconditional statements, and some of those statements can be negated using the negation symbol. And in symbolic logic, we can even use two or more basic statements and use two or more connectives or compound statements to create a more complex statements using these connections. So this is what we're doing in working out compound statements from some basic statements in set logic.